Welcome back to another Python tutorial with Simplilearn. I'm Anjali and today we'll be looking into Python scripting. So what is scripting? Scripting is writing programs to automate a task, and Python by itself is a scripting language. So what this means is that the lines that you write, the code lines, they are interpreted rather than compiled. So they are executed at runtime. So in this tutorial, we look at a few libraries which demonstrate the scripting feature of Python very clearly. Other than that, we'll also look at a few libraries which demonstrate its runtime behavior. So let's begin. I'll be coding on PyCharm today, and the first library that we look into is the OS library, which stands for operating system. So to use the OS library, first we need to import it. So say import OS. Now in here, I'll have two functions. I'll just demonstrate two of the most common functions that you can utilize from the OS library. First one is to extract the current working directory. Create a function, and I'll have a variable CWD, which stands for current working directory. Now this variable will store the return value from a function which retrieves the current working library. So you say os.get CWD, and that is it. One line and you have your present directory stored in a variable CWD. So I'll print this out, and that's our first function. So out here I'll call the function. So now we can run our program. So this is our current directory. You can see the users within the user, my particular username, and PyCharm projects /demo is this particular project under PyCharm. Okay, so that is our first function. Let's have a look at the second one. Now I'll demonstrate how you can retrieve the path of a particular file. So create another function here, and to this function I'll pass a file name. Now in here have another variable, I say path, which holds the value of the path that this file is stored in. And to retrieve that, you say os.path.apps path, which stands for absolute path. Now you know there are two types of paths. There's the absolute and the relative path name. The absolute path name is, it gives the path name right from your C drive or D drive, whichever drive it belongs to. So the relative path name is the path respective to our current working directory. Now I'll have a variable file name out here, which will hold the name of my file whose path I need to find out. So I say sample.txt, and then I'll pass this file name to my function file path. And that's it. Now let's run our code. Okay, so we have not printed the value out. Let's do that. Print path. Run your code again. The first function that we called is to retrieve our current working directory, and the second function is to retrieve the path of this file sample.txt, and this is the right path. This is exactly where I've stored my file. So all's good. So those are the two most common functions that you use with the library or the module OS. There are quite a lot more which you can definitely check out. So next we look into the time module. So as usual, first import the module. Now before I show you a few functions in the time module, you need to understand what epoch is. So 1st January of the year 1970 is the starting point of a certain timeline, and epoch time is basically the number of seconds that's passed since 1st January of 1970. So to get your epoch time, use the function time.timeoff, and I'll store the value of this function returns the epoch time, and I'll store it in a variable ppc. Print that out. So that's the number of seconds that has passed as of right now since 1st January 1970. Now obviously this has no meaning to us. So what we do is we'll convert this to a format that means something to us. And for that purpose we use the function local time. So I create a variable local time and use the function local time, to which you pass the EPC variable. Now print out local time. So as you see here, now we actually have numbers that make sense to us. We are in the year 2019, the third month, which is March, date is 18, 12 hours, 42 minutes, 47 seconds. So this is something we can actually decipher. Now again, this is a structure. It's not in a traditional formatted way. So if you want to extract certain information from this structure, you can easily do it saying local time, that you use the variable, and then just use these keys in here to extract that particular value. For example, I want to extract the year. So I say tm_year, print that, and you see here the year alone is extracted. Now if I want the entire thing to be displayed in a more formatted way, that's exactly what we have the function ctime for. For that you say print and use the function ctime. Again, to this you need to pass the epoch value, that's EPC, run our program. So now you see we have it in a more formatted way, Monday, March 18th. So we even got the day of the week in here. So those are the basic things you can do with the time module. Let's move on to our next module. So the next module we'll look at is the SMTP module. Now just like HTTP, SMTP is also a protocol. This is a protocol for sending emails. So it stands for Simple Mail Transfer Protocol. So first we'll import SMTP lib. Now in this demo, what we'll be doing is, of course, we'll be sending out an email. So we'll send an email to someone's email ID through Python. Now obviously Python itself cannot send an email out. What you have to do is you'll be accessing a domain. So you'll give the username and password for this domain and you'll put in commands here such that it automates the process of sending a mail from that particular domain to another email ID. So first we need to set a domain and a port, and for that we use the function smtplib.smtp, and so this takes two arguments. The first argument is our domain name. Now the domain name is basically like if you're using Gmail, it'll be smtp.gmail.com. If you're using Hotmail, it would be smtp.hotmail.com and so on. So I'll be using gmail.gmail.com, and the second argument is the port number, which is generally 587. Now 587 is the standard port number according to the standard encryption standard, which is TLS. Now that you have set the domain and the port number, the next thing you need to do is make the servers communicate with one another. That is basically the sender server telling the receiver server, hi, I'm present here, and the receiver server gives an appropriate response. Now in here, we'll be using SMTP.ehlo instead of HELLO. That is basically just an extended version of hello. It adds a few additional features to your SMTP. Now before that, we need a variable into which we'll store the object returned by this function. So I'll have SMTP obj. So that SMTP is the object through which we'll be referencing our domain and port number. So now you say SMTP obj.ehlo. Now the next thing we do is we'll put our SMTP in the TLS mode. So for that we use the function start TLS. So as I mentioned before, guys, this port number is the standard port number for TLS. So now it must be clear why we are using this particular port number. It's because we are using the TLS connection. So you say start. Okay, so now a connection setup account through which we'll be sending out the email. So you say smtp obj.login, and now you pass two parameters in here. The first is of course the email ID, and that is followed by your password. So to create our file, first we need to import the OS package, and in particular we need to import path library from the OS package. Now create function, and to this function I'll be passing the path at which I'll create my new file. So now before you create the file, you actually need to check if the file is already present. So you say if not, path.isFile.dest. So you're passing the destination here to this function .isFile. And if your file is already present, then this portion of the code will be skipped because our entire program is for building, because the entire purpose of our program is to build a file, which we do not need to do if it already exists. Now in here, you say open dest, w. So guys, this function actually returns true only if this file is present, and this particular path is actually a file. So suppose this destination, whatever passed to dest, is present, but it's a folder, not a file, we'll still enter this particular block. And so in here, what you do is you open this folder in write mode and say f.write welcome to Python. So let's assume destination was a folder and not a file. You enter this block here. A file is created which is opened in the write mode, and within that file, you enter the content, welcome to Python scripting. Now you're ready to close the file. Now outside here, I'll assign the path to destination. So this is the path, guys. I want to create this file sample.txt under this path. So basically, along with the path name where you're creating your file, you also pass the file name. And then you call this function create file, passing dest. And once your file is created, you can just print out file created, right? Okay, now we need to run our code. Well, we don't need an input from the user, so we say print. So we print file created. Now let's run our code. According to the statement here, there's no error. Our program executed completely and created a file. So now let's check if this actually worked. So I go to my desktop. This is the folder where sample should have been created, and yes, it is. We'll open the file, and as you can see, the content too matches. So we were successfully able to automate the creation of a file. So the first argument is the email ID. So you have the email ID within quotes, put it within single quotes, and then your second is the password for this particular ID, and that's my password. So with these credentials, your SMTP will basically log in to your account and then use the services of this account to send an email. Now the next function that will be used, the next function that we'll be using is the one that basically sends your email out. So that's called send mail, and in here you'll put in your to and from email IDs, okay? Next is the ID that we are sending the email to. Next is the from ID. I'll be sending an email to the ID enj2 Simplilearn, again gmail.com. Now the third argument to this function is the message that we'll be actually sending. So I'll be sending a very short message here. The first thing you enter is the subject, and the subject would be SMTP check. And then to move on to the next line, which is basically the body of your message, put in /n. This is a test email, and that's it. That's the body of my message with the subject preceding it. And the last thing we need to do is we will quit the SMT connection. So once your mail sent out, we'll close the connection. This terminates the program. Let's now run this code. So programs run. Now to check if this actually worked, we need to go open our account at ANJ2 Simplilearn and check if this particular message is present in our inbox. So guys, this is the mailbox that I send the email from, and this is the one that I send the email to. As you can see here, ANJ2 Simplilearn, and here is the message which has been sent. So we checked out 3 libraries in Python: the OS library, the SMTP, and the time library. Next, we'll check out a few programs which determine things at runtime. So now I'm going to write a function, func1, and this function will receive a few arguments. I'll fill in the space later on. Now all this function does is it prints out the various arguments that it receives. So suppose the arguments are stored in I, and what you pass here is also I. So you pass a number to this function, and this function prints out that number. So out here, we'll be calling the function and passing a value to it, say 10. Now what if I want to pass varying number of arguments? So say 10, 20, 30 for this particular run, and maybe the next run I want to pass 4 arguments. I want to pass 42. So how do we make this function flexible enough that it accepts any number of arguments and prints these out? That is where we have args come in. So when you put this within the brackets, what happens is that your function will take any number of arguments that you pass to it and store it in the variable args. So now to print out each value that's passed to this function, you take a for loop and you iterate that over args, and then one by one you can print each of these values out. So let's run this program now, and as you see, 10, 20, 30, 40, each of them have been printed out in a separate line. And the beauty with this function is you can change the number of values that you print. In fact, you can even give in different types of argument. So I have all integers here followed by a string, and it all works. So that is where you use the variable args. Now, similarly, we have another variable which is used in this argument space, which is called kwargs. So that's KWARGS, and you always precede this with 2 stars, 2 asterisks. So far we looked at how a function can accept variable number of arguments. Now we look into how the function can do this while accepting the arguments as values to labels. So what I mean here is, instead of just passing 10, 20, 30, what if I want to pass A equal to 10, B equal to 20, C equal to 30, and again the number of such pairs could vary. So in that case, we have args for the varying part and kwargs for the label part. So what you do here, in the similar manner, you'll have a for loop which will iterate through kwargs, and we want to extract every item in it. So we say items and print out I. Run this code, and as you can see here, so you get all the pairs printed out. So we saw how Python allows a function to determine the number of arguments it receives at runtime instead of it being fixed beforehand itself. Now let's move on to another program which demonstrates automation, and that is creation of a file. So this is one of the most common and the most basic things that you come across when you're learning scripting, not just in Python but any language. So far we saw how a function works. We have a function name, and within it we have some code to perform a certain function. Now functions in Python can also be nested, and that is what we look at now. So I'll first create a function func1, and in here I'll have a variable, say x, which is equal to 10, and within this function I'll create another function, so that will be the nested function func2, and to func2 I'll pass x, and within func2 I'll just increment x by 1 and return this value. So here's the thing, now within function 1 we need to have a call to function 2. So you say func2 and you pass x to it, and out here we'll call function 1. So result equal to func1, print out the value of result. So what happens here is you're calling the function func1, control goes in here, x is assigned the value 10, and over here there's a definition for func2, but right now it's skipped. It moves on to this return line. Now in the return line you're basically returning func2. So what that does is it'll call function 2 along with the argument x, and function 2 returns x plus 1. So where will this value be returned? Of course it will be returned to the statement from where the call is made. So that is still within function 1, and that means function 1 will return the value that function 2 is returning. So what we have in result would be 10 plus 1, which is 11. Let's now run this code. So as you see here, 10 plus 1, 11 is what's passed. So that is how nested functions work. Now why are nested functions important? They are important to understand the concept of how functions can also be passed as an object in Python and why we would do so. So I'll delete this entire code, create a function func1 once again, and in here I'll print this is first function. So that's func1. Now within function 1, I'll have my second function, the nested function, and within the nested function, I'll print out this is the nested function, and out here, I'll have a third function, which I'll call the outer function, which will print out this is the outer function. Now what I can do here is, instead of directly making a call to outer function, so sometimes what happens is you do not want to make a direct call to a particular function. You want to make a direct call to say function A, and through function A, you want to call a function B or C. So for that, what you do is you make a call to func1, and as an argument to func1, you passed another function name as an object. So I pass outer func. So as you see here guys, outer func is essentially a function, but I'm passing this function as an object to func1. So func1 will receive this function. I'll store that in a variable called func. Maybe called func will also be passed to our nested function, and within the nested function, we'll make a call to this passed function, and of course finally the return statement where we'll be calling our nested function. Let's now run this code. Our outer function was not called, and that's because we did not put these parentheses here, which does not really make it a call statement. Let's run this code now, and as you see, all our three functions were called, but through a call statement for just one. So we just called our outer function func1, passed the other outer function as an argument to this, and that took care of executing all the three functions that we have. This kind of a situation does not come handy very often, but in certain applications where you need to decide which function needs to be executed at runtime, then having the capability of passing a function name as an object comes really helpful. So we saw how you can create functions at runtime. Now Python also allows you to create classes at runtime. So let's check that out. Now the term for creating class at runtime is called factory. So what you do here is you have to basically create the skeleton or just write down the basic description for all your possible classes. So you'll mention the class that it inherits from and the attributes associated with this classes, but you do not create it, you just give that sort of definition, and then later you'll have certain expressions to evaluate which class is to be created depending on certain situations. So let's begin creating the definition for our classes. So my first class would be a base class, of course. So you say type base class, and this will inherit from the mother of all classes, which is the objects class, and following this you'll have list of all the attributes associated with this class. So I have no attributes associated with my base class. Now the second class I create, C1, will inherit from my base class, which is B, and with this class C1 we'll have an attribute named val associated to it, to which we'll assign the value 5. Now my third class C2 will be about the same thing as C1, just that this time my attribute val will have a different value, 10, just so we can differentiate between the two, and of course our class name would be C2. Now we'll have a function, say def class creator, and to this I'll pass a variable, say bool. Now if the variable is true, you say return C1, and that will essentially create your class C1. Else return C2, which will create class C2. Now outside here I'll call the class creator function, and I'll call it with both the values true and false so we can see the difference. Now of course this just creates a class, so to extract an attribute value, which is how we'll be able to differentiate between the creation of the both classes, say dot attribute name, which is val in our case, and in a similar manner we'll call class creator again, but this time with false, extract the value. So let's run the code now. So as you can see here guys, first time we pass true to class creator, and if it is true, it's creating class C1, which is this, and that has the value 5 associated with attribute val. Similarly, when we pass false, it creates C2, which has the value 10 associated with the attribute val. So that's how Python allows you to create classes even during runtime. So now that we looked into that, we are back to our nested functions, or program in which we call functions as objects. Now suppose I want to call this outer function alone. Now the question is this the only way of calling the outer function within the func1? What I mean is func1 is basically your wrapper function right now, and every function that's called through func1 comes inside this. So I want to call all the functions in the same manner, in the same serial as before, but is there an easy way to do this? Well, yes, there is. This is where decorators come handy. So just on top of outer func, if I say at func1, that way this allows me to call outer object through func1, but just with this one statement in this format. So I just say outer func, but now that I have added a decorator of func1, although I'm calling outer func, it'll be called through func1 just as before. Let's run this code, and as you see here, your func1 has been called first, and outer func has just been passed as an argument to func1. So that is what decorators basically do. They allow you to change the operation or the functionality of a function. Now this is just one use case for a decorator. Decorators are also used a lot to differentiate between static and class methods. So that will be our next program. Now both class method and static method are bound to the class. The main difference between both of them being that a class method can actually change the state of a class, while a static method is not allowed to do so. But here we are not looking into what static and what class methods are, but how you can specify them. So for that purpose, first I'll create a class demo, and I'll have two methods in here. My first method, add1, which will take the argument x, and return x plus 1. And my second method is add2, which again will take x and return x plus 2. Now I want my first method to be a class method and the second to be a static method. Now before we put in the decorators, one thing you need to remember is the class method always has self passed as an argument to it, while a static method will not have this argument self. So we remove that. Now how do you specify which method is class and static? That is where decorators come in. You simply have to say @class method, and that will define the first method as a class method. Similar way @static method, and it's done. That's how you define both of them. Now to call class and static method, as I mentioned earlier, your class method is bound to the class. So you can just say print of class name is demo. So demo dot add1, pass 10 there. That's good enough. Now our second, which is a static method, is also bound to a class, but to be more specific, it's bound to the object of the class. So you can't directly say demo.add2. You need to first create an object of demo, and then through the object you call a static method. So if you're a programmer, you know this is how static methods are always called, especially in Java, where we really take advantage of this feature. So create an object of demo and then use obj, call your static method, add2, pass 10 in there, and there you go. That's how you differentiate between class and static methods. Let's run the program. There's an error here, which is I made a small spelling mistake. It's capital O. Run the code now. So the first function, which is a class method, increments x value by 1, so that's 11, and our second method add2 gives 12. The next thing we'll be looking at is simple GUIs with Python. Now for that we'll be using a module called tkinter. So let's import that. Import ttk, which is only that particular library we need from this particular package. Sorry, it's tkinter, not ttkinter. Now first we need to create an object of tkinter type. So this is the instantiation of our object. Now first thing, we need to create a frame. So a frame is like this top level object, and all the widgets that you will be adding to the frame will be organized in a block format. That's why we have the frame, and to this you obviously pass your tk object. Those are the first two basic things. Now we are ready to create our widget. So here I'll be creating a very simple GUI which has a click me button and a label. It does not really perform anything. This is just to show you a basic demo on tkinter. You can explore this further. There are a lot of materials online. So first thing, we will be creating a label. So for the label, of course, the label would be a text. So we'll have a variable label text which will be initialized to some value of the type string var. So why we are not simply giving the value here? It's because when we are creating widgets, we often want to change the text that appears, or in some cases the text is given by the user and we need to accept that. So the only thing we can specify there is the type of the value that is given by the user, or the type of the value that will appear on the widget. So this is where we mention the type. So our type would be string var. Now we'll create a label object. So we say label, and it'll be within our frame, and what will appear as this label, the text that will appear here, that's what we need to specify. So we say text variable and label text. Okay, so I forgot to import some libraries, so I'll just import the entire tkinter package here. Okay, so we created our label. Now we can give a value to this label text. To give a value to label text, you say label text dot set, and in here I'll enter my string. This is a label. Now our second widget would be a simple click me button. So button equal to button, and the button will be within our frame, and the text that will appear on the button would be click me, and that's it. So that's all the widgets we are having here. Now every widget is put into a block format, including the frame. So for that we use the pack function. There are other formats too, and various functions to take care of these. For example, if you say label.grid and button.grid, the widgets would be put in a table-like format. So now that all our widgets are inserted into our frame, we can call the main loop. So what is the main loop? Now once everything for your application is created and you say, let's go, let's execute this application, that's when you call the main loop. This creates an infinite loop. So your program runs and it's running an infinite loop until the user terminates it. So over here we are basically displaying a user interface. Therefore main loop is the essential feature that your GUI should have. You cannot have a GUI without running your main loop. Now let's run this program. So as you see here guys, this pop-up appeared. This is the label, click me. Of course our button is clickable, but it does not do anything. We didn't add any functionality to it. Now see, as I said before, main loop puts your program into an infinite loop until the user interferes with this execution. So your loop is still running. It'll run for as long as you do nothing. You don't touch this. Now to terminate this, the user needs to go ahead and close it like that. So that is GUI with Python. So guys, that's pretty much it. We have covered most of scripting with Python. If you have any doubts regarding this, please post them in the comment section below and we'll definitely get back to you. To know more on Python, you can check out our other videos which include Python programming and Python tutorial. So stay tuned to our channel. If you like this video, please hit the like button. Also subscribe to our channel if you have not yet. So keep learning and see you all next time.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.